thank you very much everyone for coming along this evening to our RENA Scottish Branch technical presentation on the concept design of a Ro-Pax ferry by Lewis Hammell of Caledonian Maritime Assets Limited. Our sort of penultimate technical meeting for this year. The final meeting will be on the next and final meeting will be on the 24th of May, and that will be our annual RENA Student Award evening in cooperation with BAE Systems. And the details of that will be coming out shortly, and that will be accessed through the same platform as we're using at the moment. So there'll be an opportunity to register for that coming out in the next few weeks. You might note on the appointment email that came out for this event on Sunday evening, there was a minor error in that the speaker was announced as Matt Howard. Obviously, Matt was the speaker for our last presentation. I'm very pleased to say it's actually Lewis who's given the presentation tonight. So, for a bit of background and introduction, Lewis is a naval architect. He graduated from Strathclyde University in 2016 with a master's in naval architecture and marine engineering, and very shortly after that he secured a position with CMAL as a graduate naval architect. He's been there for almost 5 years, covering a range of different projects, vessel types, and upgrade projects, new designs, and dry dockings, a whole host of activities that the company are involved in. And more recently, his main role has been being involved in the concept design of the vessel you'll hear about this evening, and the small vessel replacement programme that CMAL are undertaking at the moment. I'm also very pleased to say that Lewis is also a member of the committee of RENA Scottish Branch, which has got nothing at all to do with us being able to force him to come along this evening and give this presentation. So tonight, Lewis is going to take us through the process CMAL have been through over the past 18 months in bringing together the concept design for their new ferry serving Islay and Jura. As we go through, if anyone wants to ask a question, there's an opportunity to do that at the end. But we'd ask if you could make that known through the group chat, either by giving an indication of the question you'd like to ask, or indicating that you'd like to ask a question at the end. I'd also ask if everyone that's not involved in presenting or asking questions could keep themselves on mute, just to make the presentation flow a bit smoother. But otherwise, I'll hand over to Lewis for his presentation this evening. Thank you very much.
Okay, thank you, Malcolm, and hi everyone. My name is Lewis Hammell, as Malcolm said, and I'm an Assistant Technical Superintendent and Naval Architect at CMAL. Tonight I'm going to go through the kind of concept design and also the feasibility studies that we've carried out for our new Ro-Pax vessel. We have been working on it for about 18 months now, probably a bit longer than normal. Obviously, COVID has played quite a huge part in that, as well as some other challenges that we'll kind of discuss through the process. Just quickly, just to provide you a bit of background about CMAL, Malcolm's obviously provided some background about myself. So just for hopefully most of you aware, the kind of role that CMAL plays in the ferry services for Scotland. So we own 36 ferries for both the West Coast and the North of Scotland, the West Coast being the Chiefs contract and the North Coast being the NIFs. CMAL also own about 26 port facilities, which consists of ports, harbours, slipways, link spans, etc. And we are a government-owned public company, and our headquarters, which you can see in the nice bright sunny picture in Port Glasgow, and we've got roughly about 35 employees. Just to give you a wee bit of the structure behind CMAL, we have a vessels team, a ports and infrastructure team, finance team, and our corporate team, and quite a number of projects going on with just a small number of employees. Just to hopefully most of you again are aware of the kind of network. So as I mentioned, we have the West Coast with the Northern Isles. It's probably quite difficult to see in the graphic, but I'm sure we're all kind of aware of Scotland's kind of geography. So we do have diverse geographical locations. I think it's easy to say that no two locations are the same. We do have an ageing fleet with a multitude of requirements, and this new Isla vessel that I'm going to talk about tonight really is the kind of beginning of completely refreshing the fleet. We do have a range of berths that range from concrete slipways for the smaller vessels to the link spans and passenger access systems for the kind of intermediate and larger vessels. And then we also have a large range of stakeholders and communities that we engage with through all of these projects. The Hammell fleet in particular, so as I mentioned, with 36 vessels, 31 of these are for the West Coast, which, as I said, was the Chiefs contract that is operated by Calmac Ferries Limited, so that's the Caledonian Brain service. And we're split into small, intermediate and major fleets, the smallest vessel being 12 metres, ranging right through to the Loch Seaforth, which is 117.9 metres. And then for the 5 vessels, we have the North Coast, which is a NIFS that's been operated by Serco Northlink, and that consists of 3 Ro-Pax vessels and 2 Ro-Ro freight vessels. Just to give you an idea of the vessels team, so we have a number of projects going on, but there are only 5 of us in the team, and we will actually be conducting interviews at the end of this month for a new graduate naval architect / engineer. And we also have the shipyard site supervision team, bit of a mouthful that one, that are based currently in Ferguson Marine. So Jim, he heads up the team, he's the director of vessels. We have Andy and John, who are project directors and fleet superintendents. And then we have myself and Declan, who are both assistant technical superintendents and with a background in naval architecture. Unfortunately, Declan was supposed to present tonight on some information for passenger-only vessels. Just given the kind of status that project's at, we're only giving the presentation one, but hopefully Declan will be able to provide some information in the future. Just to give you an idea of some of the projects, so we have the Glen Sannox NATO 2, along with the LNG bunkering infrastructure that's going on with that project. That's all I'll say about that. We also just have, you've maybe seen the news release quite recently about the small vessel replacement programme, which is looking to replace up to 7 vessels for the small vessel fleet, with a number of those vessels being built around about the 1986 point. So looking at an extensive programme for that. The Goodall to Noon passenger only replacement, as I just mentioned there with Declan, we're looking into the feasibility studies and concept design of new vessels for them, and also looking at the potential for the Cregan route as well. We have the High Seas Free concept design, which I'm sure people have maybe heard about. High Seas 1 and 2 was led by Hammell, with High Seas Free originally being passed over to Ferguson Marine. It's since now kind of in the way back to Hammell leading the concept design. We also have, quite, as I've mentioned, 36 vessels. So we have the existing vessels inspections. We would carry out a dry dock inspection and a summer inspection on a Hammell behalf, and also all the upgrades that go with the vessels, and that's for both the Chiefs and the NIFS contracts. And then we're also working on a concept design for a Northlink freight vessel replacement. But the main project that I want to talk about tonight is the replacement vessel for Isla, and it will also serve Jura as well as Colonsay. So just to give you a bit of the project background. So the next major vessel in the Chiefs network, it was announced way back in 2018, now about 3 years ago, and it's the vessel to serve Isla and Jura. And again, as part of that route, we include Colonsay as well. So the vessel is set to replace the MV Hebridean Isles, which you can see in your top right corner there, which was built in 1985. And it's to complement the MV Finlaggan, which was a bit more recent in 2011, although approaching 10 years old now. The vessel is to be more orientated towards a freight service, but still to have sufficient passenger accommodation to meet anticipated demand, rather than just being a kind of Ro-Ro vessel, if you like. And our main project goal is to design a modern ferry that is reliable, efficient, environmentally friendly, safe and comfortable. And I've just provided you a table there to just give you an idea of some of the kind of main details, the main particulars about the 2 existing vessels, and mainly looking at the length, roughly 90 metres for the Finlaggan, 85 metres for the Hebridean Isles. You can see there the difference between the deadweight and the cargo deadweight. The reason there's a range there for the Finlaggan is just it really does depend on the operating conditions. Quite a difference in the service speed between the 2 vessels, where we have 16.2 knots for the Finlaggan and 14.5 knots for the Hebridean Isles. So both kind of currently doing slightly different timetables. However, because the Finlaggan's got a larger capacity than the Heb Isles, it does need a bigger turnaround time when it's in port. Then have the split of cars and HGVs there. Again, we'll touch on cars, but it really does depend on the car size. So this is just kind of using like an equivalent unit. Passenger capacity is 560 and 450, and then crew cabins is 34 for Finlagan and 26 for Hebridean Isles, and that does include some spare cabins, particularly for Finlagan. Now to kind of take you through the vessel concept design and feasibility study. So to kind of go through the process and show you the different options that we have considered. I'm sure most people will be aware of the kind of different phases of the vessel design, but it's just to kind of make it clear who is responsible for each. So the concept design phase is the responsibility of CMAL, and we employ naval architect design consultants to develop the vessel concept design along with ourselves. We don't just kind of say how we can do it and show us what we have. We work with the naval architect consultants and their specialities to produce the vessel design, and that's got to meet all the functional requirements such as the service and the vessel statement requirements that's produced by the operator. When we then move to the kind of tender and contract design phases, the shipyard are responsible for this, and we'll touch on the kind of procurement phase a bit later. And then, of course, the detailed design and the build of the vessel is all the responsibility of the shipyard. I have given you the little graphic at the right there. I won't go through each section, but you can just see what's kind of expected from the different phases. We then work closely with the shipyard so that the vessel that we want is what we're getting pretty much. As I mentioned, we have a site team that's currently based in Ferguson's with the 801-802 project, and a similar process will happen for the New Isla vessel when we get to that stage. The vessel design has to comply with the following. So we are designing to the EC directive, which is still currently what, according to MC, what we'll be designing to, even though the UK is now out of Europe. All of the relevant IMO regulations, classification society rules and regulations, and the MCA rules and regulations.
I think I lost the sound there, Lewis.
Oh, sorry. Where about what at? You hear me okay?
I can hear you fine, Lewis.
Yeah, I can hear you fine. Yep, cheers.
All right, okay, right, no problem. Carry on. So where do we begin with then? We begin with the design considerations, which is in a report called the Vessel Replacement Deployment Plan, and it kind of highlights these 6 key features, not in no particular order. We have the safety and reliability, the cargo deadweight capacity, manoeuvring, berthing and station keeping, sea keeping and passenger/crew comfort, redundancy, and then fuel efficiency and emissions reduction. And that really helps inform the kind of service and vessel requirements. So as I say, we are providing a vessel for service, which is the Isla route, and then that helps inform the vessel statement requirements, which is provided by the operator, which is CalMac. So the requirements that we have for this vessel set out at the beginning was reliability and resilience, so an increase in service reliability compared to the existing vessels, reducing greenhouse gas emissions, reduce in overnight noise in port, meet the existing timetables with the same crossing time as Finlagan, meet current bunkering timetable, which is currently 2 times per week at the kind of mainland port of Kennaicraig, clear driving height of 5.1 metres underneath the stowed mezzanine decks, provided a bit more information on that later on, provide as a minimum the same as Finlagan for deadweight and payload, cargo deadweight if you want to call it, and maximise vehicle deck space and provide bow and stern loading for the vessel. We also have to make sure we provide an open air zone for the carriage of dangerous goods. For passenger capacity, we're looking at a passenger number of 350 passengers. Passenger facilities, in the modern facilities we've come to expect from the kind of CalMac vessels, with 1 retail outlet, which would be in the form of a mariner's cafeteria. Accessibility, a very key part of all vessel designs, particularly ferries, is to make sure that all areas of the vessel are accessible for passengers with reduced mobility. Provide 31 crew cabins, all to be located above the vehicle deck. In terms of crew facilities, we look to provide best welfare facilities, including crew gym, laundries, offices, etc. Provide working areas for crew throughout the vessel, including stores and workshops, and then provide provision stores for passenger and crew provisions. So that is the kind of main service and vessel requirements. Some of the design limitations that we have on the route is particularly surrounding the ports, which we'll kind of come on to as you can see here, we've got the 3 primary ports, which is Kenneth-Craig, the mainland port, and then the 2 Isla ports being Port Ellen and Port Askaig. We then also have the 2 secondary ports that the vessel will have to serve on a kind of smaller basis, being Colonsay and Oban. You can then see I've highlighted underneath what the kind of main limitations are. The ones that are circled in red are the serious kind of limitations, with the orange ones being kind of a bit slighter, and then of course the one circled in blue is issues that we have to work around, but not as kind of drastic as the others. So for Kenneth-Craig, big issue being the water depth, which of course affects us increasing the draft of the vessel. The pier structure, Kenneth-Craig pier, is nearing life expiry, which we'll come on to in a wee second, but obviously affects the displacement of the vessel. The concrete ramp fit at Kenneth-Craig, there is both a link span and a concrete ramp. The vessel currently does use both sides. The link span is the main fit, but we have to make sure the vessel works with the concrete ramp as well. No shore power currently at Kenneth-Craig. Gangway, I don't know if you've ever visited Kenneth-Craig, but it's quite a small platform that the gangway works off of. So we've got quite a small window to put the passenger doors into. And then fuel bunkering, as I mentioned, Kenneth-Craig is where fuel bunkers are taken on board, and we do look to provide them both so that bunkering can be done via the shore and also via the car deck. Port Ellen, quite similar to Kenneth-Craig, is the water depth and pier structure. Not as critical though, the pier structure this time compared to Kenneth-Craig. The space for approach into the berth. The marshalling areas is quite a concern with a kind of significant reduction compared to the capacity of the vessel that we're wanting to provide, but we'll provide some more details on that later on. And again, no shore power currently at Port Ellen. Port Askaig, the biggest limitation we have at Port Askaig is the pier length. Finlagan currently overhangs the pier, so if we were to ever make the vessel longer, then it would become more significant. And also going inside and with the overhang of the pier is quite strong currents coming through the Sound of Isla. Then mooring arrangement is obviously affected by the pier length. Link span fit, not as big an issue as we have for, say, the concrete ram fits, but having to make sure we line up link span. Again, no shore power provided at Port Askaig, and the marshalling area is a limitation, but not as significant as Port Ellen. And the reason I mentioned, the no shore power for the 3 primary ports is because the vessel is expected to tie up at these 3 ports at certain times during the timetable overnight. For the secondary ports, shore power isn't a concern because the vessel would never be tying up overnight. But for Colonsay, the water depth is an issue, with it being one of the more shallow ports around the network. Again, similar to Port Ellen, the pier structure affecting displacement is a known kind of limitation, and similar to space for approach. And for Oban, given that most of the major vessels are operating in and out of Oban, there's not too many concerns, apart from making sure that the passenger doors line up with the passenger access system. And just a little note there that Kenneth-Craig, Port Ellen, Colonsay or Oban are all owned by Hammell, and Port Askaig is owned by Argyll and Bute Council. Just to give you an idea of some of the companies that were involved in the feasibility studies, so as well as the concept design, we also have port feasibility studies ongoing at the same time. So we have been working with these companies, and it's all been centred around the statement the requirements for the vessel, as well as the policy set for the service. So our main consultant throughout this project has been Naval, who are a naval architect and specialise in ferry design. Naval are based out of Flensburg, with a number of the members of the staff working in the shipyard previously. Naval have then been using HSVA to help with all hydrodynamic research, all CFD calculations, etc. And again, HSVA are based in Hamburg. We have carried out a dynamic mirror analysis for each port, and we've used Royal Haskonian for this. Jacobs have been a civil engineering contractor working for Port Ellen and Kenneth-Craig, and similarly Arch Henderson have been doing any studies for Port Askaig and Colonsay. We have had the kind of help of Lloyd's Register throughout this, representing the kind of classification society, and of course the MCA helping out with any matters as the flag state authority. And then we have been involved with various major equipment suppliers who, given the stage we're at, I won't name just now, given that we're quite close to going out to procurement. Feasibility analysis options. So basically, we looked at these 5 options, and 3 of the options, which you can see at the top, were carried forward for kind of further detailed analysis. One option, being a kind of longer vessel, over 100 metres, was kind of written off quite quickly, purely down to Port Askaig and that limitation at the pier, and it'd be quite an overhang of the vessel being 100 metres. The option 5 is to looking at 2 new vessels. However, this is going to be considered at a future point. So just to give you an idea of the 3 key options, the first one is almost a like-for-like replacement, slightly optimised, but in same speed and size as Finlagan. So a kind of 90-metre vessel, if you like. Option 2 is replacing the Hebridean Isles with a new vessel, circa 95 metres, with greater vehicle capacity than option 1. And then option 3 was looking at 2 smaller vessels, roughly 70 to 75 metres, with the same combined vehicle capacity as option 2. What we've looked at then, carrying these 3 key options forward, is a range of feasibility studies during this concept design. So includes the service and operation requirements. Yes, these are set at the beginning, but we have to keep evaluating them and making sure that they all make sense, and then go back and revisit any. Maximising vehicle capacity, as we've said, freight has been a big goal for this project, so maximising vehicle capacities is key. Looking at the forecast demand in relation to the freight, passenger and vehicle requirements, arrangement for passengers and crew, accessibility in the passengers areas, the vessel operating speed, port fits, limitations and improvements or enabling works, emission and fuel consumption analysis for the vessels, air quality, reliability, manoeuvrability and seakeeping, shore power and overnight noise, the benefits and disbenefits of each of the vessel options, the costs, including the capex and the opex of the vessel options, and then of course the timetables. So without going through every single detail that's on this slide, this gives you an overview of the 3 options. So it has the main particulars and has the costs at the bottom. Again, some notes and assumptions aside, which I won't go through every one, but feel free to read at your own leisure. So just to kind of go over the key main particulars. So as we said, option 1 was also almost like-for-like replacement of MV Finlagan, which is 89.8 metres length, 16.4 metre beam and 3.4 metre draft, similar displacement and similar deadweight. Option 2 vessel slightly increased in terms of 5 metres longer, increasing the beam to 18.17 metres and increasing the draft with a design/operating draft of 3.8 metres and a maximum draft of 4 metres. The option 3 vessels, which we look to provide 2 of, as I said, 70 to 75 metres, 15.7 to 60 metres, and then a range of draft of 3 to 3.4. As you can see, the displacement of the option 2 vessel means slightly more than the option 1, and then of course slightly less for the option 3. Similar deadweight between the option 2 and option 1 and cargo deadweight. Maximum speed, we'd be looking at, again, kind of 16.2 knots for the option 1, 16.5 knots for option 2, but a slower speed for the option 3 vessels, given the size of the vessels. Passenger capacity, we'd look at 350 for both 1 and 2. Although Finlagan has a slightly higher passenger capacity, 350 is what's been set for this vessel design. And then if option 3, it would be 200 per vessel. Cars would be 77 compared to 100, and then 100 for the 2 vessels. 10 HGVs compared to 14. And then regardless of vessel option, it'd be 27 crew cabins with 4 spare cabins for training of crew and cadets. If we then compare the costs, so option 1 estimated capital cost would be £48 million, option 2 would be 50, and then option 3 for the vessels combined would be 56 million. The operating costs over 30 years, as you can see, option 2 has the lowest price, and it's quite a significant difference for option 3, given that we'd be running 2 vessels, more crew, more fuel, etc. Port work costs, so the biggest difference would be obviously option 2. There would be a number of enabling works, which we'll go into a bit more detail for the option 2 vessel. There still would be some smaller works required for the option 1, particularly at Colonsay, and then for option 3 there wouldn't be any works required. And then shore power costs would look to be done for each option, regardless of the kind of successful option. Moving on to kind of some further detailed analysis of these 3 options, and mainly in relation to the fuel consumption and emissions. So giving you the annual operating hours at sea there. In terms of the timetable, as I touched on before, it would look to be the kind of same as the Hebridean Isles. It would go at the same speed as Finlagan, but then we require an extra bit of turnaround time, so the timetable wouldn't change. The total estimated fuel consumption for the crossing, including the hotel load and the sea margin, this is assuming diesel electric propulsion, would be 1240 litres per hour for option 1, 857 litres per hour for option 2, and 1034 litres per hour for the combined option 3. If we then look at that as fuel consumption per car space per hour, 16.1 litres, which is almost double the option 2, and then again higher for the option 3 compared to option 2. If we then kind of go down through the CO2 per car space per hour and then per year, you can see again option 2 is the lowest, and then you can see some differences there between the different options and what we've saved for option 2, which is quite significant. And just a little note there, as I touched on before, the option 3 vessel would be going at a slower speed than the two larger vessels, so it's not directly comparable between options 1 and 2. Sorry. To try and kind of simplify all this, we look to put this into a table with some ratings. So green being kind of the best, being rating 1, amber being rating 2, and red being rating 3. So that kind of traffic light system. So not that every option could have a 1, for example, if you look at down near the bottom of passenger capacity, because they would all be very similar. But again, without going through every single one, it's quite clear there that you can see that option 2, although it does have the initial higher capital cost and the port works are required, then the benefits for the option 2 vessel far outweigh this, which leads us to the conclusion. So the detailed analysis of these 3 options established that vessel option 2, which was a 94.8 metre vessel, has significant benefits compared to options 1 and 3. And vessel option 2 also has significant benefits compared to the existing vessels currently serving the route, being Hebridean Isles and Finlaggan. Therefore, option 2 was the preferred option for this route. But as I've mentioned, for option 2 and its corresponding benefits for you guys, port enabling works are required, which I'll come into a wee bit more detail in a second. But the analysis that we've carried out shows that the benefits of option 2 outweighs the costs of the port enabling works. So that takes me on then to this preferred vessel option, which is the option 2, and I'll provide the kind of the concept design studies that we carried out for this vessel option. So option 2 provides an optimised hull form. So you can see the main particulars over there on the side. So 94.8 metres length overall, 87.9 between perpendiculars, the beam 18.7 metres, not including the belting, the draft 3.8 to 4 metre maximum. This all provides a block coefficient of 0.574. Our dead weight 750 tonnes with a cargo dead weight of 476 tonnes and a maximum speed of 16.5 knots, but I'll touch on speed a wee bit more. So as you can see, the number of benefits there that we just pick out, and this is just looking at the hull form in particular. So it does provide an optimised hull form, which provides lower emissions and carbon footprint, lower fuel consumption, lower fuel costs, lower energy usage, increased vehicle deck space, improved seakeeping, which in turn improves passenger and crew comfort, reduced drift due to deeper draft, improved propulsion effectiveness due to the deeper draft. And the hull form and hull resistance for option 2 has been developed and verified by experts in the field of hydrodynamics. Just to give you a little snippet of the difference in the hull forms, which you can see here. So we have Finlaggan on the top and the new vessel hull form on the bottom. Not sure if there's any hydrodynamic experts out there, but you can see quite a significant difference in the 2 hull forms. Moving on to the propulsor type. So during the feasibility studies and the concept design, we have considered a number of options for propulsors, and this has included kind of the conventional CPP, which all of the major vessels in the fleet currently utilise, azimuth thrusters and cycloidal propellers. The cycloidal propeller has been used in the Hammell small fleet. Following our analysis, our preference was for either an azimuth propulsor or a cycloidal propeller type. And the main advantages of these 2 types over the conventional CPP are the increased manoeuvrability, the increased reverse thrust, a lower propulsion power required to achieve the full reverse thrust, and a lower response time from a head to full astern. To go into the vessel speed, so for the route, Finlaggan currently has agreed speed limit with the local communities to reduce wash whilst travelling through the West Loch Harbour. So currently the vessel reduces its speed from 16.2 knots down to 12 knots, and this is approximately for 20% of the journey time. So one of the goals we set ourselves at the beginning was to investigate how we could potentially reduce this wash and whilst increasing the speed. So we carried out a far-field study, and this was done with HSVA in Hamburg, which you can see a snippet of on the side. The bottom half of the image is the new vessel going at 13.5 knots, and on the top side is the Finlaggan at 12 knots. So during this far-field study, it was found that the optimum slow speed for the new vessel hull form would be 13.5 knots, meaning we'd be able to go 1.5 knots faster than the Finlaggan through the west locked harbour. So to kind of put that in pictorial view for you, we've got 3 lines here. We've got the red dotted line, which is Finlaggan. So Finlaggan, we've got the example here of departure from Isla, where she's up to 16.2 knots. And then when we reach the west locked harbour, after the open sea passage, she's having to reduce away down to 12 knots, quite a significant difference to the maximum speed. And then we have the arrival in Kennecraig. The Heb Isles, due to its hull form and being a smaller vessel, doesn't produce the same wash, so is able to travel at the full 14.5 knots of the full way. Still, it takes 10 minutes longer than the Finlaggan's journey. So our goal was to provide the kind of optimum speed, if you like, optimised speed, where we'd be travelling at a certain speed through the open sea passage, which in this case is 15.7 knots. And then we reduced down to 13.5 knots in the West Locked Harbour. Again, we are trying to arrive at the same time as the Finlaggan because we require this extra time for turnaround time due to the increased capacity compared to the Hebridean Isles. Again, I mentioned 15.7 knots, but the vessel will still be capable of doing a maximum speed of 16.5 knots. And to go into then speed power predictions, which again have been carried out by HSVA and Hamburg. I've picked the kind of 4 key speeds there that we mentioned. So the 12 knots that Finlaggan does through the West Locked Harbour, the 13.5 knots which the new vessel is proposed to do, the 15.7 knots, and the maximum speed of 16.5. And you can see between the Finlaggan and the new vessel quite a significant reduction, particularly at higher speeds of 16.5 and 15.7, a significant reduction between the Finlaggan compared to the new vessel. The figures that are used for the Finlaggan there is known data, and the figures for the new Isla vessel is approximate data based on CFD calculations, and this will be further defined during model tests, where, fingers crossed, the results might be even better than what they currently are for the new vessel. Just to give you an idea of some of the energy efficiency considerations that were included in this new vessel and will be included in the technical specification. So of course we've touched on the optimised hull form, which has been provided by a longer and larger, more efficient vessel. The optimised speed, as I've touched on, the machinery propulsion plant, as I'll go into in a wee second, the lower energy consumption, super premium efficiency, low voltage electric motors to be utilised, LED lighting throughout the vessel, waste heat recovery systems, smart HVAC systems, well-designed galley systems, hybrid solutions and battery technologies, hull coating systems, and then of course shore power. Just moving on to the dynamic mooring analysis studies. So I touched on this previously. So this dynamic mooring analysis study has been carried out by Royal Haskonian, and it's been carried out for Kennecraig, Port Ellen, Port Askig and Colonsay for both vessel options 1 and option 2 to provide a comparison. These studies highlight any issues with the vessel's berthing at expected ports during various wind and tide conditions. The studies conclude that both vessel option 1 and 2 can berth safely at all the ports, but option 2 provides greater reliability and can berth in more challenging conditions when compared to option 1. And both sides of Kennecraig and Port Ellen piers have been considered and are available for operations. And there's just a little example of a polar diagram on there. I believe this is for Kennecraig, and you can see the difference between the north berth and the south berth, which really does provide a bit of an advantage because in certain weather conditions you can use the other side of the berth. Port Askig is limited to one side, as is Colonsay. However, it's good to have this option at Kennecraig and Port Ellen. Moving on to station holding windows, and I do apologise, I think I've deleted somehow the propulsion machinery concept, so I can touch back on that in a wee second. The option 2 vessel, so as you can see the little images up in the top right corner, comparing with the Finlaggan, there's approximately a 6% increase in windage. So we currently have 1,202 metres squared on the Finlaggan, and the predicted windage for the option 2 vessel is 1,272, so only a 70 metre squared increase. The majority of that is down to the increased garage height of 5.1 metres below the stowed mezzanine deck compared to Finlaggan's 4.6 metres, and then of course the rest is accounting for the additional length. For the propulsion power, so we currently have 2 times 4 megawatts on the Finlaggan, but for the new vessel, we're looking at 2 times 2.2 megawatts. Bow thrusters, currently in the Finlaggan, we have 2 times 600 kilowatts, and on the new vessel proposed to be 2 times 880. And this is down to the fact that we've got a larger draft in the vessel, which can produce larger tunnels for then larger thrusters. The option 2 will have enhanced station keeping, as depicted in the graph there. So current in Finlaggan, the max wind speed against the beam is 36 knots, but for the new vessel is 43.7 knots. Moving on to the vehicle deck arrangements. So for the option 2 vessel, as I've touched on before, we have 750 tonnes of deadweight, and we're looking at 476 tonnes of cargo deadweight. The HGV capacity is 14 times 33 tonnes, or 10 times 44 tonnes plus 24 cars. But we do have space for 14 HGVs, again, if they are all fully laden, which is not likely to happen, but there may be some scenarios, then we can take 10 fully laden HGVs. For the cars on the main deck, as you can see in the drawing there, we have 77 shown. However, we'll put a range 73 to 77. Again, this can all completely depend on the size of cars. What's shown on the general arrangement there is a standard car unit, roughly 4.95 metres by about 1.95 metres. And then similar for the mezzanine decks. We can get up to 30 cars, but again, this might be reduced to 27. So the idea is that the vehicle deck will have 5 car lanes, we'll have 4 commercial lanes, 2 hoistable mezzanine decks, 1 double deck and 1 single deck. And the rationale behind that, rather than 2 doubles, is because it provides a bit more flexibility with the HGVs. As I've said, one of the goals is maximising the freight capacity on this vessel. So the actual space between the 2 mezzanine decks, we can actually get HGVs down that space, which is similar to the Loch Seaforth if you've ever been on that vessel. Also provide the open zone for the carriage of dangerous goods, and then we'll provide electric vehicle charging points on the vehicle deck. Just touching on the hoistable mezzanine car deck, so particularly with regards to the clear heights, the Finlaggan currently only has a clear height of 4.6 metres, but for all our new vessels, it is intention to provide 5.1, which it just makes loading operations a wee bit more flexible, provides more space, means we can get HGVs underneath the mezz decks when they're not deployed. When the mezz decks are deployed, we also gives the benefit of having 2.9 metres underneath the deployed mezz deck, which allows you to get higher sided vehicles underneath the mezz deck, depending on the size of camper vans that we're carrying, of course. And this is all depicted in the 2 graphs that you can see there, the 2 drawings you can see there, sorry. Sticking with kind of the loading operations, so the vessel port interfaces. So we've, as part of this concept design, we've carried out terminal fit studies, checking all the vessel port interfaces such as ramp fits, bunker stations, passenger access, and making sure we've done it for all the primary and secondary ports for the Isla route. So as I mentioned before, we've got the 2 sides at Kennaicraig where the primary operation is Bowen, and then the secondary operation is Bowen. However, also looking to do sterning, at both of these ports. For Port Ellen, again, we have both sides, but for both sides, we only look to go sterning. For Port Askaig and Colonsay, also sterning. And then for Oban, the primary operation is Bowen, but we do look to see if the vessel can go sterning as well to provide a bit of flexibility. So these terminal fit checks also include any changes to terminals that are required for any port enabling works. The vessel bow ramp interfaces with all link spans and fixed ramps, no issues, so happy days there. And also the increased beam of 18.7 metres provides a wider clear driving width for 4 metres compared to the Finlaggan's 3.5 metres, which allows for unobstructed flow of wide loads. Currently, the Finlaggan has to go stern in to allow wide loads off the stern ramp as they can't get through the bow ramp. So the 4 metres provides a bit of an advantage there. For the stern ramp, so I touched that the bow ramp was all good, but for the stern ramp, there is a number of link spans and concrete ramps that we've got to try and fit with. So it's quite difficult to have a kind of one size fits all. So we have this solution, which I've probably shown you before, that we have on the Glen Sannox. However, on the Glen Sannox, this is manually operated and has a limited range. Whereas, given that this will maybe have to change every second sailing between likes of Port Askaig, Port Ellen, Colonsay, this will be electro-hydraulically controlled. And you can see the different positions there. So showing the centerline position, the Port Askey position, and then the different positions for Port Ellen. And if I can just show you this little animation. So this animation is taken from the Glen Sannock stern ramp, which should hopefully begin any second. There you go. So you can just see how the outer section moves from side to side. So on the Glen Sannock, this will be manually done, but we look to have this hydraulically done on the Isla vessel, and it allows easy operation. Also, the plan is that the ramp can move in when the ramp's in the vertical position, so it's nice and quick for the crew to operate. Moving on to the passenger spaces. So as I've said, we have looked at a passenger number of 350, and this has all been analysed using the forecast demand, mainly by CalMac and Transport Scotland, but it's all the group that agrees on this number. So a maximum of 350, but we are looking to put all seats internally, but still provide about 100 to 150 seats externally that won't be counted as part of the passenger capacity. The passenger layouts and tier scheme is currently being developed by an interior architect, which you can see some of the early representations. No guarantee it's going to look like this. However, just gives you an idea of kind of what the look and feel we're going for. I don't think white chairs is the intention, it's just probably very early days. And obviously, I'm sure most of us are aware the kind of challenges that are associated with the passenger accommodation is accommodating and facilitating the 350 passengers, which is a nice number to deal with compared to some other vessels where you're trying to fit in 1,000 seats. Providing the life-saving appliances and evacuation for those passengers, which I think always kind of is sometimes forgotten about. The LSA they take up quite a large amount of space on the vessel. Things like MES stations, the lifeboats, the life rafts, all takes up space. Provide a range of comfortable seating, so we're not just providing 350 recliners everywhere, providing different areas for the passengers. And then, of course, as I've touched on before, providing accessibility for everyone. Just a very high-level layout of the passenger areas. So the whole concept behind the passenger areas is to have the passengers forward and have the crew accommodation aft in a kind of more slender section. On the main passenger deck, which would be deck 5 level, it might be quite difficult to read, sorry, but I can kind of go through them. So we have, starting from the kind of centre, midship, we have the passenger entrance area, moving out into the kind of family lounge, the social lounge. We've got a recliner lounge and a pet lounge, as well as all your facilities for toilets, first aid room, changing place, accessible toilet, games area, children's play area, these kind of things. And then a passenger lift between the two decks. Moving up to the upper passenger deck, which in this case is deck 6, is the kind of cafeteria, main cafeteria, as well as a quiet lounge. And we have the Mariner's Cafeteria retail outlet in there, as well as the galley, which is serving both the passengers and the crew, rather than having a galley on one deck and then a crew pantry on the other deck. As I've touched on before, accessibility is a key thing that we have to look at when designing the vessel, particularly when looking into the passenger areas. One of the most important being the lift access. So lift access, there'll be 2 lifts on the vessel, and the access provided from the vehicle decks to all passenger areas. So there'll be a forward lift providing between the vehicle deck and the 2 passenger lounges, and an aft lift that provides access between the vehicle decks and the external passenger area. As well as the lift access, lift size and features. So one big advantage of having the increased beam compared to the Finlagan of 18.7 metres, it provides more space in the side casings, which means we can have increased lift sizes, which meets accessibility requirements, providing a 1.5 metre turning circle. Also, all the fittings within comply with the standards you can see on the screen, the EN 8120 and 8170, which is for the design of the passenger lifts. Also look to provide a sounding loop system to be fitted in both the lifts and then accessible toilets. The passageways always look to have a kind of minimum width of at least 1200 to 1500 millimetres for the passenger walkways. Again, the increased beam of the vessel makes this a bit easier when designing the passenger areas, as does increasing the width of the passenger staircases from both the vehicle decks and between the passenger decks. Handrails, maybe one that not everyone thinks of, but fitting handrails at 2 different heights for accessibility. Again, we'd probably look to provide this mainly on staircases, but look to do it throughout the vessel as well. A changing place toilet, which you probably start to see in more and more places. So a facility that's a bit more than just an accessible toilet, and it has to meet certain guidance. One of the key ones being 12 metres squared floor space minimum, and there's a number of kind of features within that changing place, such as adjustable height bench, adjustable sink, etc. And then again, an accessible WC on the opposite deck from the changing place, which is kind of more standard accessible toilet. Designated wheelchair spaces to be provided in all the different seating areas. Height adjustable tables, a minimum of 4 throughout the cafeteria and then also throughout other areas in the vessel. And double height counters at any reception or serving counters, double height counters will be incorporated. And then another kind of small one, but again very important, is the staircase nosings. So having the colours on the staircase different from the actual flooring for visually impaired passengers. Moving on to, so I'd mentioned for the option 2, for the benefits to be realised, then port enabling works are required. And these port enabling works are mainly at Kennaicraig, Port Ellen and Colonsay, with some kind of more minor works at Port Askeig. So at Kennaicraig, Port Ellen and Colonsay, dredging is required to allow for the maximum draft of 4 metres. But again, as well as allowing the deeper draft for this vessel, it also future-proofs the ports for future vessels, where 4 metres is our kind of target to achieve everywhere. Also required at Kennaicraig, Port Ellen and Colonsay is fender upgrades and replacements, and this is to allow for the larger displacement vessel. But again, it is also future-proofing the port for future designs and for other vessels that may want to use the ports at any time. An installation of a semi-automated mooring aid on the pier at Port Askeig. So you've got a little example there in the picture on the right for Stena. This is taken in Belfast, where it's a Murex system. And this is basically the intention of fitting this at Port Askeig is to counter the vessel overhang and strong tidal flow. But we are kind of working on some last minute clarifications to see what rating of Murex is required. So still some kind of ongoing works there. So as I've said before, the benefits of the option 2 vessel outweigh the costs of these port enabling works, particularly relating to fuel consumption, emission reductions, and as well as the projects that I've kind of mentioned there, there's going to be 2 independent projects that will run alongside, and that is the Port Ellen Marston area, also known as Port Ellen Phase 2, and the Kennaicraig Pier, which you may hear as Kennaicraig Phase 3. As I've touched on back in the limitation slide, Port Ellen Marston area isn't fit for purpose even for the Finlaggan, so work has to be done for the Finlaggan and any proposed new vessel, and Kennaicraig Pier is approaching life expiry, so we will be looking to have a new pier. The new pier will likely be after the vessel arrives, but there'll be some kind of small minor works done to the current pier to ensure the new vessel can berth there and that the benefits can be realised. And touching on shore power, so as I'd mentioned before, there's no current shore power available at Kennaicraig, Port Ellen and Port Askeig. So we have done some feasibility studies with SSEN to see how possible it would be to put shore power there, and good news is. So this allows the vessel to be plugged in overnight and can also be used for charging energy storage devices and batteries on board the vessels. The emission reduction is estimated to be 10% for the option 2 vessel by using shore power overnight. And if the Finlaggan is retrofitted to use shore power, then it's estimated to be 6% overnight. And of course, using shore power overnight then negates the use of a generator on board, which is currently done by Finlaggan and the Hammell, therefore eliminating overnight noise in the ports. Particularly useful in Port Ellen and Port Askeig because the ports are right within the local communities where there's houses and hotels nearby. And then just to give you, to finish off, to give you an idea of the benefits and the comparison with between the option 2 vessel compared to current MV Finlaggan. So in terms of lower emissions and carbon footprints, we're looking at estimated 31% less emissions. Lower fuel consumption is also 31%. That relates to about £550,000 per year of a saving in fuel costs and a 28% daily energy reduction. We also would have improved redundancy by utilising diesel electric propulsion. As I've touched on, we look to have an optimised speed for the open passage and through Westlock Tarbert. The vessel has increased car capacity, 100 versus 77, which is a 30% increase. And then 14 HGVs versus 10, which is a 40% increase. And then using a lower number of 27 compared to 16, provides a 69% increase for cars for the hoistable car deck. And then increased manoeuvrability by using either azimuth thrusters or the cycloidal propellers. And then just to kind of summarise and to kind of provide the way forward for the project. So as I've touched on, option 2 is the preferred option for the Isla route. We are just working on some last minute clarifications, as I've kind of touched around about the mooring aid system. So following those clarifications, hopefully by the end of this month, we anticipate moving to stage 1 of procurement for the new vessel, which is the call for competition, also known as the single procurement document. And hopefully that's done by the end of Q2 2021. Following this stage 1 of procurement, it's then expected that a shortlist of up to 6 bidders would go forward to stage 2, which is the invitation to tender, which is also known as the ITT stage. And then, given that the ITT stage will probably take maybe about 9 months, we are hopeful of having a contract awarded to a shipyard by the end of this financial year, by Q1, Q2 2022. Assuming a 27-month contract period for design and build, that would provide a vessel delivery of Q2, Q3 2024, depending when the contract's awarded. And again, these are planning dates and could be subject to change, particularly given the pandemic that's going on, particularly with the ITT evaluation of shipyards might be delayed due to the COVID-19 pandemic and we've been able to travel. And that's all myself. So thank you very much for listening. You can keep up to date with the project at the website you can see there. You can also view any webinars and presentations that we've done to local communities before. So please feel free to go on and look at them. We also have quite a substantial Q&A document where there's been many questions asked and we've provided the answers between CMAL, CalMac and Transport Scotland. You can also email us at ilavessel@cmassets.co.uk if you have any further queries. But again, thank you to the branch. Thanks to everyone for listening. Thank you.
Yeah, thank you very much, Lewis. It's a very interesting presentation. I think we've got a few questions on the chat so far, so I'll pass over to Chris just to take us through those, if I can.
No problem.
Yeah, absolutely. So I will start off by reading these off, but if anybody does want to actually ask Lewis a question, I'll open it up to the floor and take a question. Lewis, you did say there's certain things that you don't want to talk about, so if we can keep things to this project alone.
Yeah, it'd be great to answer questions about this project.
Not a problem. So first question I will ask you is, says, with regards to the 3 option specs used in the rating matrix, some parameter units were per car per year. How is the assumption that all car space capacity availability is used up through the year ensured, whilst having a higher OPEX? Arguably a split argument given the job creation opportunity. Option 3 would provide more flexibility with 2 slightly smaller vessels versus option 2 with 1 larger vessel.
Yep. Okay, so, sorry, lost you there. I suppose the biggest reason between the option 3 and the option 2 vessel really is the operating costs. So when you look at it over that 30-year period, there's quite a substantial difference between the two. And sorry, what was the point, Chris? I missed a bit at the start. Just on, was that talking about the?
How was the assumption that all car space capacity availability is used throughout the year ensured?
Yeah, sorry. The passenger capacity used throughout the year.
How is that ensured?
That really does come down to CalMac and just keeping track of how it's all utilised. Again, obviously, there'll be a peak period during the summer compared to during the winter, but we've carried out all the forecast analysis and we're confident that those kind of figures are the right figures.
Okay. Second question is, have you considered the effect of electric vehicles on the vehicle deck, firefighting or fire containment? What implications does this have for the design?
Yeah, it is something we have considered at this stage, but again, it is something we'll probably discuss the implications of of the vehicle deck and firefighting systems with the shipyard at the detailed design stage. It has been looked at, has been considered, but I think it'll be more for the detailed design.
If I can just expand on that as I asked the question there, I've seen a few comments from various people with experience of both firefighting and of ship operation, that essentially with a lithium battery fire, the only thing you can do is douse it with water to cool it and hope until it goes out of its own accord, which obviously introduces, requires that you be able to provide a very high volume of water on the car deck, and then for the ship to remain the right way up with a very large volume of water on the car deck. Hence, I think there may be some interesting challenges arising from electric vehicles as they start finding their way onto Ro-Ros.
Yeah, no, I think it's a really good point, Robert, and it's something we have already considered for the Glen Sannox in 802. So it's almost like a kind of fitted with the provision for providing the sockets on those vessels, but I don't think they'll be operational straight away. So we are kind of considering it through that project, and then obviously be further hopefully considered during the detailed design of these vessels.
Does anybody else like to ask a question before I start reading the many that have popped up on the board?
Can I go first?
You can indeed.
Thanks very much. First of all, congratulations, Luis, for making such a very competent and interesting presentation. It's Professor Vassalos from Strathclyde, so it's just demonstrating my pride to start with. Just two questions. One, when you design a new vessel, I would expect that you look to compare it with what is available in the market, state of the art, not
yes.
with a tired 30-year-old vessel and prove that it's better. So that's my first question. Have you considered what is available in the market, pick up the best, and then prove that your design is better than the best? And the second, I haven't heard anything about safety in your presentation, and being a passenger vessel, that should be the foundation. So is there any reason why you omitted safety in your presentation?
Not on, thank you very much, first of all, for the comment in the presentation, but in terms of safety, it's not kind of omitted from the presentation in any way. I mean, the vessel will be built in accordance with the EC directive, so we'll have to apply with all the safety rules and standards for passenger ships. Again, we have been in touch with the MCA in class throughout the concept design, and it obviously will be looked at again further through the detailed design, but we have ensured that the vessel will apply with all safety rules and regulations. In terms of the vessel comparison, I mean, you're spot on. Obviously, that's the reason we haven't compared with the Hammell is because we don't see the point in comparing with a vessel that's 30 plus years old. So we've compared with the Finlagan, given the Finlagan, I mean, it's for our fleet, it's relatively new. I know 10 years isn't exactly new anymore, but that's why we've done the comparisons with the Finlagan. In terms of comparing to what's already out there, we probably haven't done any direct comparisons with what's out there, but I think it's very much been taken into consideration by ourselves in the value when designing the vessel, what's already available in the market.
Okay, that's reassuring. Thank you very much.
Thank you, Professor. The next question on the board is from Donald Patterson. It's quite a long one, so Lewis, bear with me. To echo the questions above about the traffic light charts and had a safety rating of 1 green, what has been considered in this determination? Specifically, I'd be interested in understanding how damage stability performance has been considered, which is of particular significance in light of new and more stringent SOLAS 2020 regulations. And Donald, you forgive me if I take a quick break there. What have you done for 2020? Your SOLAS 2020.
Again, for that one, we would be saying that we have been designed to SOLAS 20. Not sure if the expert in Malcolm could come in there. But we do comply with all the kind of latest regulations. We have been in contact. Sorry, Malcolm.
I can comment if you're happy for me to. I think it was a key discussion point when we got involved in the project quite early on, that you were looking at. I think there was a number of different options for compliance, and as far as I'm aware, at the moment it's been presented on the basis that compliance with SOLAS 2020 is what the design will aim to achieve, and I think the preliminary study has been done on that basis.
Yeah, absolutely. Yeah. We kind of started this project off early stages in August 2019, and we have been engaging with the MCA and class as well from the get-go, pretty much. So, although it is a concept design, and I would say it's a very well developed concept design in that sense.
To continue the question on, so you've answered part of it. Is it the intention to have the vessel SOLAS compliant or according with MCA? So I think you've just touched that there. And they've then said, from the passenger capacity, the required subdivision index would be around 0.722. However, the ease with which a given concept design may reach this requirement will vary. So it would be interesting to know how this has been accounted for in decision making. Do you have a comparison of attained subdivision indices for the different concepts?
It's not something I know off the top of my head or at hand, but again, we would be happy to answer that question. I don't know who's asked that question, but if you've seen the Isla vessel mailbox I put up, if you want to get in touch with that, we can provide some information.
Next question is around manning. Why a crew of 27 when other operators manage with circa 14 crew? For example, Pentland Ferries, 98 car ferry, 434 packs, or Bodo Lofton, 13 crew, 380 passengers, 120 cars.
Yep, no problem. Can answer that. Obviously, I haven't touched on it there for this presentation. If you go on our website, you will be able to see webinars we've carried out with local communities, and we do touch on the crew levels. And the crew levels really are defined by the safety requirements, so the safe man and the muster list requirements. And then both of these require approval by the MCA. We then also have to comply with the hours of rest regulations, and then in accordance with the service specification, as I kind of touched on, the service and vessel requirements that we receive from Transport Scotland.
Question is, does CMAL intend this to be a design and build contract? If so, why is CMAL producing a design, and what does CMAL expect the winning contractor to do with it?
Yep, so it will be a design and build contract for the shipyard. We always do to a degree of a concept design prior to the design and build to make sure that we know what we're asking for works. Also, as I touched on, probably used the term feasibility studies quite a lot. We really did look into a lot to see what was achievable, how much could we stretch the main particulars. It also required the investigations for the port works as well, kind of side by side. So we've really kind of got all those investigations out the road at an early stage so that we've got real confidence when we go to the shipyard. Again, as I said, I would say it's a pretty detailed concept design. I'm sure shipyards will probably be open to having their input, and maybe they might change things about, or they want to do this or want to do that. But I think it just gives us a lot of confidence going forward.
One last question before I open to the floor again. What software has been used for designing the hull and for running the stability?
I'm not too sure. Again, I don't have that at hand, but for stability, I would imagine it would be Napa.
No. Opening to the floor, has anybody got a question they'd like to ask? Oh, yes. David. Sorry, not David. Alan. Alan, do you want to?
Can I ask Louis what you've done so far? It's really all from design point of view, what you outlined. Have you given any thoughts from the operator's point of view, crew-friendly or safety-friendly features?
Yeah, Chengi, yeah. I mean, I maybe didn't touch on it there because I just didn't want to confuse everyone, but this really is, CMAL are the project lead on this. We do kind of lead on the design, but Transport Scotland and CalMac are involved throughout this project. They've been involved throughout the beginning. CalMac set the statement of operational requirements. They have a chance to review all the drawings along with us, review the technical specification. They see the crew arrangements, the passenger arrangements. So CalMac have a master and a chief engineer dedicated to reviewing the kind of documents with us. So yeah, CalMac have been along us with every step of the way, and will continue to be throughout the design and build as well with the shipyard.
Alan, are you unmuted?
Yes, I have unmuted. Thank you. Of course, all this is based on your forecasts for passenger and vehicle increases, but the history of CalMac or Scottish Ferry forecast has not been particularly good, with demand always filling the space available, particularly in the summer. What sort of increase in demand have you assumed for the peak season?
Sorry, I can't remember the figure at the top of my head. Again, we have all this. We have answered all these in a Q&A document, Alan, which I can provide information to you on. I think 4% rings a bell to myself, but I don't want to commit to that in case it's not the correct one. But what I would say is, I understand it's been raised quite a few times in the public Q&As that we've done in the webinars. But Transport Scotland and CalMac have a lot of confidence in the figures that we're going with.
So 4% per annum.
Yeah, I think that's.
Yeah, I mean, well, it's a long time. It's history now, but we were involved in the late 70s and early 80s, and the forecasts which were done by consultants were wildly pessimistic compared with the subsequent size of vessels that had to be built. The other question I had, how confident are you in the actual power savings that you're making? They seem to me to be quite significant, and of course they won't be realised until you've done model tests.
Yeah, we have a lot of confidence. I mean, we have previous experience with HSVA from the Log C4, who done the CFD calculations and the model tests for that vessel. So yeah, I think we have a lot of confidence in these figures, and as I said, hopefully when we do the model test that it proves why we were confident. But yeah, I think we have a lot of confidence in them.
Yeah. Okay. Thank you. And I should have said thanks for your presentation. It was very interesting.
Thank you very much. Thank you.
Malcolm, we have quite a lot more on the board. Shall I just keep going? I think I'll take that.
Yeah, well, just give another couple, Chris, and then I think we'll draw it to a close if that's all right.
Yeah. Question here: why a monohull when a catamaran could achieve capacity with less length overall, less draft, etc.? The Pentland Ferry's Alfred apartment is 3,000 megawatts of power for 16 knots.
Yep. So we have, again, I've not covered that in this presentation just due to the kind of material and the time kind of given, but I would refer everyone to the link I'd shown. The January presentation we done, which included a webinar to the Island Jura communities. We presented information on the monohull, so the option 2 monohull versus the catamaran, and for this Isla and Jura route, the monohull has many benefits and compared to the catamaran. So I can provide the link to maybe for Rob to share with everyone. The information is provided in that.
And I'll make this next question the last one. The Isla route has a higher rate of weather-driven cancellations. Will this new vessel be more reliable in that sense?
Yeah, well, we hope so. Again, the use of either the azimuth thrusters or the cycloidal propellers really could provide a big advantage in that over the existing vessels. And we have obviously done the studies with the station holding, and as we've seen there, quite an increase for this vessel compared to the Finlagan, even given the higher windage. But yeah, we have a bit of confidence that the reliability of this vessel will be higher than the current vessels.
Just a brief question. In your comparisons with catamaran, which design did you use?
It's a design that's, unfortunately, I can't share. It's the design of the consultants that we're working with Naval.
Is it a real ship or is it a concept?
It's a concept.
And is the concept a good one?
I'd like to think so, yes.
How do you know?
Well, based on the experience of ourselves and the consultants.
There's not much experience of catamaran, so how do you rely on experience?
Well, I think you have to take the experience of the consultants we're working with. They won a tender for the contract for the concept design of the vessel, so we have a lot of faith in the work that they've done for us. And also, as well, the consultant they're working with, HSVA, who are a world-renowned expert, who have also been involved in the catamaran concept.
Is that available for scrutiny?
I don't know. I think that would have to go to a higher level myself.
It's a government business, so it would be good to have this available for us to scrutinize.
Okay, I think, I mean, at this stage, as I've said, it is the property of the consultant, so we'd have to check. But again, Dracos, you're more welcome to send either myself or Jim Anderson an email. And
excellent, thank you.
Okay, no problem. And maybe just before I finish, sorry, apologies, I don't know what happened. I deleted one of the most important slides out of the presentation by accident, which was the propulsion concept. So I don't know if you may want me to share it, Malcolm, just very quickly.
Oh, please do. Yeah. Just, if it ties your presentation together, yeah, why not?
I don't know what happened, but I have it from a different presentation. So if I can find it, doesn't seem to want to. So can everyone see that? Okay.
Indeed.
Yep.
Okay, so just to kind of go through the propulsion concept of the option 2 vessel. So it is a hybrid lithium-ion battery diesel electric propulsion system with either this concept's got the azimuth propulsor in, but again, we're also looking at cycloidal propeller. And the vessel will be equipped with, so as they are 2 times 2.2 megawatt propulsion units, 4 times 1530 kilowatt medium speed diesel low sulfur MGO generators, 2 800 amp to 1000 amps, obviously will be further investigated during the detailed design, shore supply connections, 2 AC premium efficiency electric propulsion motors, and then 2 530 kilowatt lithium-ion battery banks that can be used for peak shaving, in-port manoeuvring and slow speed, and then the 2 times 880 kilowatt transverse bow thrusters. We did consider LNG fuel during the feasibility studies, but due to the low power requirements for the option 2 vessel and the range of available engines, we decided against going for LNG. And you can see the little very high level kind of power balance up there. We've got the 4 generators, the battery banks, hotel load, the 2 bow thruster units, the shore power, the electric motors, and then the 2 propulsors. So apologies that somehow didn't make it into the presentation.